What is a control valve? A control valve is a device used to regulate the flow of a fluid in a system by varying the size of the flow passage. Explain the main components of a control valve. A control valve typically consists of a valve body, actuator, and a positioner. The valve body includes the trim, seat, and the plug or disc that controls the flow. The actuator is responsible for moving the valve, and the positioner ensures accurate positioning. What is the purpose of the positioner in a control valve? The positioner enhances the performance of a control valve by adjusting the valve position based on the signals it receives. This helps in achieving precise control and maintaining the desired set point. Differentiate between throttling and on-off control valves. Throttling valves regulate fluid flow continuously, while on-off valves either fully open or fully close the flow. Throttling valves are used for precise control, while on-off valves are suitable for applications where flow modulation is not critical. Explain the significance of the CV flow coefficient in control valves. CV represents the flow capacity of a valve. It indicates the volume of water in gallons per minute that will flow through the valve with a pressure drop of 1 psi. A higher CV value signifies a larger flow capacity. What is the role of the actuator in a control valve? The actuator is responsible for moving the valve to control the flow. It receives signals from the controller and adjusts the valve position accordingly, either by pneumatic, hydraulic, or electric means. What are the common types of control valve actuators? Actuators can be pneumatic, hydraulic, or electric. Pneumatic actuators use air pressure, hydraulic actuators use fluid pressure, and electric actuators use electrical power to operate the valve. Explain the term, valve trim. Valve trim refers to the internal components of the valve that come into contact with the process fluid. It includes the plug, seat, and other elements that directly influence the flow of the fluid through the valve. Why is backlash important in control valve applications? Backlash, or dead time, can impact the responsiveness of a control valve. Minimizing backlash is crucial for achieving accurate and timely control in a system. How do you troubleshoot a control valve that is not functioning properly? Troubleshooting involves checking for issues such as air supply, instrument signals, and potential mechanical problems. Inspecting the valve trim for damage or blockages and ensuring proper calibration can also be part of the troubleshooting process.